Let's talk about basic stuff here, okay? The unit of charge that we're going to use, the symbol for charge is a Q, like that, right? And the unit that we're going to use is a Coulomb, okay? A Coulomb is actually the amount of charge you have if you have an ampere of current flowing for 1 second. And an ampere is cleverly defined in terms of newtons and meters. So these are MKS units, right? So just keep that in mind, right? The only difference between charge and mass is that charge is a signed quantity. So you can have positive things like for example, protons are positively charged, right? Electrons are negatively charged. Now keep in mind there are lots of charged particles that are positively charged and negatively charged. They're just not as common as protons and electrons. And then this is the fundamental, this is the basic charge. This is one of the, I would memorize this number. Okay, this is the charge on an electron. It's also the charge on a proton, right? So if you have an electron, it's negative this charge. If it's a proton, it's positive this charge, okay? And this, we think, is the smallest charge, although quarks could carry a third or 2/3 or something like that. We just never witness isolated quarks. So quarks are the things that make up protons and hadrons and mesons. And then we don't really use this, but a Coulomb is that many electrons or protons. A Coulomb is such a crap ton of charge that we actually rarely deal with coulombs themselves, right? So a microcoulomb is 10 to the minus 6, and you'll see microcoulombs in a lot of problems. Okay, so just keep in mind that micro is not just a decoration, right? Charge is conserved, just like mass energy and things like that, right? Angular momentum and energy and stuff like that, right? But charge is a little bit more complicated because you can have repulsion and you can have attraction, right? Whereas with mass, you have only attraction. Okay, I think that's all we need to do here.